So now that I've finished the implementation of stacks and queues, I'll be moving on to the linked list implementation of stacks and queues. I'll just be covering the basic concepts in this. Now, as you can see in stack, as you've already seen, there's only one pointer, but in linked list implementation, we use something which is known as a node. In a node, there are two different parts. One part consists of a pointer and another part holds the data. Now, if I enter a value 65 inside the stack, the head pointer points to the data value, that is 65. Now, this entire box where you can see 65 and this space is known as a node. What this denotes is that 65 is the value which is held by the node, and this is the pointer of the node. The pointer of the node points to the value of the next node. Now, since a stack works on the first in last out option, the values entered last will be the first value which the head pointer will point to. So yeah, let me enter a few values. So now that I have entered 5 values, I'll explain what's going on over here. So basically this is the head node or the root node, which consists of a pointer which is pointing to the next node's data, which I have entered last. So when I enter a data inside the stack, these entire four nodes they move aside, that is, they literally get pushed to the side, and the entered data becomes the first data which is pointed to by the top pointer. Now when I pop a data, let's see what happens. So basically the pointer's position, or the pointer's value, the top pointer's value is simply changed, because instead of pointing to this value, when I pop it, it will point to the next node's value. This is what exactly happens. So I keep popping the data. As you can see, the pointer's position, or the value to which the top pointer actually points, becomes different. And again, since it is a stack, it is working on the principle of first in, last out. Now since 65 was entered first, when I pop it, 65 will be the last data which has been popped, and 65 will be the last data to be removed. So this is how the linked list works, or this is the linked list implementation of stacks. So the points to be noted for this is basically, in linked list implementation there are the uses of nodes, and nodes is basically divided into two parts, which is the data and the pointer. Now the pointer is used to point to the data of the next node, and the advantage of using a linked list implementation is you needn't have an array. You don't have to initialize an array with n number of free spaces. Instead, only the amount of data which you require can be used in linked list implementation. Hence, there is no wastage of space.